This lecture is being recorded. And so we're here to talk today about HTML5 Canvas and using it to make games. So the first part is going to be a little bit of an introduction to HTML5 Canvas, and then we're going to build an endless runner game together, and that's probably going to take us through the end of lecture. Basically, to get started, how many people have played video games on a browser?
Me.
Do you remember back when you would have to install Flash to do it?
100%. It was the bane of my existence.
Yeah, it was awful. So to start with, to talk about HTML5 Canvas, kind of just as a little history, it's kind of wrapped up, or it starts off where the browser wars ended. So there was a time when everyone was fighting over browsers. There was a lot of competitions, and then Microsoft Internet Explorer won that fight for a while, right? And in that time, they pulled a lot of their staff off of Internet Explorer, and Internet Explorer stayed the same for a very long time, which is why your Internet Explorer in 2003 or 2004 had 3,000 viruses, had a bunch of toolbars you had no idea what they did, and also every single website you went to told you to install Flash multiple times over, to the point where even if you were an incredibly advanced security person, you weren't always sure if you actually needed to install Flash or if they were just finding a really nice excuse to get a virus onto your computer. This culminated in eventually building this kind of, it's not an alternative to Flash, it does kind of different things, but it like encapsulates a lot of the behaviors that Flash would have otherwise done for us. When Chrome or when Google Maps and Google Gmail like made JavaScript really take off in a big way, HTML5 Canvas was developed as kind of like an alternative that would allow us to do a lot of drawing and doing a lot of cool things on the browser without having to make a user install an entirely different app, which can lead to a lot of like security issues where you have to tell the user, hey, go to this link and install Flash. And then people will be like, okay, I'm going to virus.com and installing Flash. So HTML5 came about to kind of like, and it started getting all these features that Flash did. And eventually, Steve Jobs penned this little message, thoughts on Flash, saying, we're no longer packaging Flash in with Macs. Flash is something that should die because it's very, security-wise, it's very unsafe. It's proprietary, it's awful. Use HTML5. Steve Jobs, April 2010. And that sort of was the death of Flash, but also came about with this like resurgence of like HTML5 and HTML5 Canvas. And HTML5 Canvas is at heart, allows for dynamic scriptable rendering of 2D shapes and bitmap images. And they've also been like doing some stuff to make it 3D. We're going to be talking a lot about 2D stuff today. If you want to use it to make things 3D, that's a little bit more challenging, a little bit more experimental, but it's something you can do. So let's start with it. Here is a page that I have on my browser on index.html. It looks like this. We're importing one font that I want to use later. I'm sorry, Kyle. I know that's tough, but you have a real garden that you can use instead of using Farmville. So at this point, right? Like you'll notice that I have this like little canvas with an ID of game, a width, and a height. Now, canvas is at heart just an HTML element. It is like an H1. It's like a div. It has some cool additional features, but it is at heart a box. In this case, a box with 500 pixels of width and 500 pixels of height. Right? That's just something we have written here. I'm going to say right now, everything you draw on canvas will not change the HTML. It's a purely a JavaScript thing. The HTML will still look like canvas, ID of game, width of 500 and height of 500. Think of your canvas literally as that. It is basically a little like canvas that you do your painting on. And I like to think, and I'm going to continue to use the painting analogy a little bit more. But before we go any further, I just want to like show you this is something that has a width and a height of 500. If I were to load in a script that
Hey,
manipulates
Nicky,
it, yeah,
can I interrupt real quick?
yeah.
I'm sorry I'm coming to the party late here, but you're talking about Canvas and HTML5 here, and the project that I was kind of leaning towards doing was something very similar with JavaScript Canvas. Is this
Yeah, this is
is this
exactly.
going to be cool?
Mhm. Sorry, just messed up a drinking coffee. Yes.
All right,
We're talking about using JavaScript with HTML5 Canvas, which is basically how you use HTML5 Canvas is with JavaScript, and I'm going to show you how that's done today.
okay, thanks.
But as we like cover off on this, noting that it doesn't change the HTML, I do want to be really clear. Canvas, very cool for animations, very cool for games. What it is not cool for is rendering useful content on your web page because it has none of the accessibility features that regular HTML does, right? It's not going to set up an e-reader for you. It's not going to allow e-readers to read it. So it is useful for animations and for games, but if you actually want to start using content, you're gonna have to do something a little like you're not going to be like and showing content on the page that you want people to read. Don't use Canvas. Cool. So now we're going to get into what it does. Basically, I have a couple of demo scripts here that were built by my colleague and good friend Ian Hollander, who none of you know. But here is a sample script that's just going to use HTML5 Canvas. Right? We'll refresh the page with this new script, and now we see a pretty cool S being formed, right? Cool. It's a basic thing that Canvas can do. The code looks like this. It's a little interesting. I'll comment on another one, and we'll show you something else. Boop, boop. Here, I'm going to refresh the page, and now, ooh, right? Exciting. You're noticing nothing is changing in my HTML, right? I think there must be like some sort of timeout that makes this go faster every now and then because it seems to be going much faster. Cool. I'm going to comment this out before it scares me. And then we can go back to index.html and we can start working on this, right? Index.js. And I'm going to be doing this with a couple of classes. I'm also going to be using some functional stuff. I'm going to be way less class oriented than I normally would be because we're pretty limited on time here, and I want to like show more cool things rather than just like refactoring and making sure things work. We might get to that point. I don't know. Whenever I do this lecture, I halfway through like see some different way to code something and then code myself into a new corner. But I'm going to now go back over to this page, and we're going to grab this canvas. So you're noticing it has an ID of game. Document.get element by ID game. Const canvas. Cool. Can everyone see this? Should I zoom in? Good. Cool. Now, Canvas has something that we call the context. And this is going to be something that we can use a lot. And it's going to be something that I'll show you right now. Const context equals canvas.get context 2D. Cool. This is how you call the context for the first time. Get the context, and here is 2D. There are a couple of other ones you can use. There's some experimental ones for 3D. I'm going to console.dir context, and let's start talking about it. The context is basically, the way that I like to explain it, it's like if you use MS Paint, right? Everyone's favorite art tool, right? Like, you don't just start drawing. Like, you can. We're drawing right now, right? But usually, to do something in MS Paint, first I'm going to be like, I want a paintbrush that looks like a big round box, and I want it to be red. So I click those two things, and then I can start drawing, right? I can say, hey, I want a box. I want it to be filled, red, want an outline of black. And now here we go. Or I screwed that up. Let's try that one again. Bloop. And now we've got this, right? So you code in Canvas much the same way that you do MS Paint. For those of you who are as familiar with MS Paint as I am, you dip your tool brush or you dip your paintbrush into like the color that you want, how you want it to be depicted, the font you want, and then you start drawing. And that's what context basically does for us. So I'm going to show something right now. Once I have the context, I can say context dot fill color. Nope. Fill style equals red. Cool. And this is just something that I can. Also, you'll often see context written as CTX or something else. If you go through like W3 schools. But I'm going to say context is fill style in red. I'm dipping in the red paint. I'm going to do context dot fill rectangle. I'm just going to say from 0, 0. Let's do x10, y10, width 30, height 30. So context is our tools. It's basically our toolbox that we can use to manipulate Canvas. So I've just created a rectangle that I made red, starting at 10 pixels, 10 pixels, with 30 width and 30 height. Context works like this. Its coordinate system is like this. 0, 0, width, height. And yes, it's all made possible because a canvas has a context that you can get. And you can be like, hey, I'm getting the context for 2D here, right? And when I say get context 2D, what I'm saying is give me all the tools to modify this canvas with 2D graphics, right? So now that I have this, I'm going to keep this here because this is going to continue to be kind of weird and kind of like when you get to actual geographical space in video games, that's always going to be something that melts your brain a little bit. Like, because unfortunately, say, hey, go to the bottom of the screen, right? I'm going to actually have to do something. Like, if I wanted to say, hey, put a box right here. I'm going to have to say H minus box height. And I can definitely. I said I was good at MS Paint, but yet I can't write things using just the cursor. Box height, right? So I can show you right here. Context, dot fill, rect. I can say 10. We've got a canvas, dot height, minus 30. 30, 30. And now we have a box at the bottom. You're noticing the previous one doesn't disappear. We can stack a whole lot of things. And if we make two different things happen, they'll just put it on top of each other. I can demonstrate right here. All we're doing is drawing, and it has this, like, it's even like MS Paint in that once you've dropped a box, it's going to forget that that box exists, right? It's going to be like, cool, it's on the page. I don't have to worry about it. It's no longer a thing. It's no longer an object. It no longer has behaviors. It's no longer a rectangle. It's just that now the pixels look like that. So that's going to make developing a little weird, right? Now, at this point, we can start talking about how we're going to build our games. Do we have any questions or weird bits about context before we go into that? Cool. There's other things you can do, right? You can do, I think you can do fill text. And I can say hello. And I can say canvas.width over 2, canvas height over 2. And now we've got a little hello here, right? We can make decisions about font, right? Context.font. It's probably not the easiest way to Google that. And I can say, like, hey, I want this to be, yeah. Wow. This brings me back to first grade, something that looks like this. Cool. I can be like context.font equals bold, 48 pixels. And then the font that I've decided is, I think, press start to P. Now if I try this again, we've got this, hello, looking like this. I can even say right here. Oh, last thing I should show you. The way that you clear your context is context.clear, rect, cover. This is a very common thing I'm writing all the time. Create a clear the rectangle that covers the entire canvas. And here we go. And now.
So is that basically redrawing a blank canvas over the top of the existing one that you already created?
Yeah, it's clearing the canvas in that spaces. I don't think it draws a new canvas on top of it. I think it just clears everything on the canvas in that box that you've defined. I can say, does that answer your question?
Yeah, thank you.
That's going to be really helpful for us because obviously a game should have more than one frame. You can also do like text align. I think, yep. Context.text align equals middle. Oh, and I'll show you that in a sec. Now if I do this, it's going to be mean to me again for some reason. We'll solve that in a bit. But now we can get on to building this game, right? At heart, we're building an endless runner game. So Chrome has one as a little Easter egg if you go offline. So let's go offline right now. Offline. Let's make it look like an iPad. Cool. Test this out. Cool. So you notice how there's this little dinosaur right here in Chrome? If you actually click on it or hit space, it'll actually start up an endless runner game for you. And you just, right? So this is what the game is, right? Everyone a little familiar with an endless runner game? Cool. That's what we're going to be building here. So I'm going at this point. I've broken down kind of what our goals are. We need to draw a rectangle, which I've already shown you a little bit of how to do. We need to animate the rectangle. We need to give ourselves the ability to start and stop the animation, turn the rectangle into a player, make the player jump, make the player stop jumping, make an obstacle move, make the obstacle move, don't make too many obstacles, make the game end when the player hits an obstacle. When we get all these done, we're done with the game. Everything in a game comes down to, like, every time I build a game, I like start from, okay, let's get this on the page. Cool. Let's make this thing actually behave in a certain way, right? So I'm going to, at this point, take const canvas equals document.get element by the game. Context equals canvas.get get context to D. Cool. We're all good so far? Now, if I want to make a box, we've shown how to do that, right? So draw a rectangle. We can say context, but what do we have here? We had fill style equals red, context, but fill rect equals fill rect 0, or let's start at 10 or 30. And I said earlier, if I want to start the bottom, right, I'm going to need to do canvas.height minus whatever the height of this bad boy is, right? So at this point, I can just say, let's say we're going to give it 80 height for now. Width 40, height 40, 80, right? And take a look and we can refresh the page. Boop, and now we've got a rectangle. Do you all see how we did that?
Sort of.
Yeah, so we basically just said, hey, make a rectangle. Fill it using the fill style. Said 30, that's this distance right here. We said, hey, the y, right, is always going to be like this right here is what is like, this is the y we want, right? Because it starts from the top left, right, when we draw. So for this, we actually needed to go, hey, for the y, we should actually do the canvas height minus the height of this box. So that was our second thing.
Okay, cool.
And then this width 40, height 80. We refresh the page. There we go. Now, if we wanted to imagine like animating this, right? Have like a context.clear rect 0, 0. No. Stop that. Canvas.width, canvas. We're gonna be that way, huh? Cool. Arguably, right? If I want to make a jump, I would just, the way that we do, like, the way that film works, right, is like it's just a series of frames that together become something that's a little bit less static, right? So I'm just going to do a little debugger right here. And really what we kind of want to do, we want to make this look like it was jumping. Sorry, right here. We can do something like, oh, be good? There we go. Right, I just put a debugger between each of these like frames, right? Now, whenever I go to the next debugger, it's going to show that if I like, what I did here was I just redrew it each time, clearing it, adding 10 to it, clearing it, adding 10 to the height, or really subtracting 10 from the height, subtracting 10 from the height. And by just doing that, we got something to animate within the debugger. If I close the console so the debugger doesn't fire, it happens all at once, right? So we don't actually see an animation at all, right? Those of you who have been to Flatiron School and who have gone through a couple of mods might be able to say, hey, you can actually abstract some of this logic, right? For an animation. We could have it in, like, right here, say, some sort of like player. Why? This is the part where it kills me. I'm realizing that I'm going to have to make this decision, and it's going to be really important and instrumental later on. Cool. And now we can have like a little function. Add 10 and render. Let's call it add and render. And I can say right here, do something like this. Now if I go over here with this new function I have, subtract and render, right, player.y. Oh. We can start seeing how this would eventually move, right? Do you see how we did that? Cool. So at this point, right, ideally, the way to make it, if we just want to make it keep going up off the screen, right, we would want some sort of way to just loop this, right? Now, I wish we could call this like loop. And I wish we could do something like this, right? What would happen if I did this?
You'd have an infinite loop, wouldn't you?
I would, right? Which is sort of what I want, right? I want it to just keep doing that and then rendering, right? Unfortunately, you get a maximum call stack size exceeded, right? Now, I could do something monstrous like set interval loop 1. Do this loop. And there we go. We've got like a little bit of an animation going, right? This is exciting. For a bunch of reasons, set interval isn't the best tool you can use to build out a game. One, it sets out a race condition that, hey, every single piece of logic in the event loop has to be completed within 1 millisecond, right? Which is probably a bad thing, right? Because then you get stuff to start to stack up. There's a couple of other things that make it not really great for this. Instead, JavaScript has a little cool tool that's going to help us do this for us. It's called request animation frame. And it's a property of window that just says, hey, I want to perform an animation. And basically, it's designed to do exactly what we want it to do, right? Like, hey, once you're done with all of the logic, render the next frame, right? And it's going to do that for us. And you might be like, hey, but isn't the logic kind of inconsistent? Yeah, this does probably affect the speed somewhat, but like, not like, it's still way better than using set interval, right? And it does make it really, really, it does make a lot of this work really, really neatly. So I'm going to just go back here. Got this. If instead, basically the way it works is you initiate it once, and then you say window.request animation frame, and then you pass in the callback. And it's going to do something very similar. It's slower because it's actually working quicker than 1 millimeter or millisecond. No, it might be working more slowly than 1 millisecond. I have no idea. But now I can say something like 4. We can test this. And it's just basically it goes, hey, let's do this logic. Once you're done with that animation, request the next one. Do that. Cool.
So
yeah, go ahead.
why does that not cause like a stack in the same way with having a like calling it recursively inside it?
It's designed to do this by like JavaScript specifically to like not like add to the stack, right? This is actually working kind of synchronously, right? This is going like, hey, go through this. Don't add something to the stack till you're done. And then like once you're done, just go make the next thing on the stack doing this, right? That's my guess for how it works. Anyways. And together, this whole thing, this recursive thing, is called the game event or the game loop. And it's a really, really common pattern for games, right? So now we have the ability to draw the rectangle, and we have the ability to animate the rectangle. Next, let's give ourselves the ability to start and stop the animation. Cool? I am going to create, let's say, let pause equal pause. Then I'm going to say, hey, document dot there we go. Add event listener key down handle key down, and here make a function that I'm going to call handle key down, takes in an e, and console.logs e.keycode. When you have a key press event, you have a key code method. You have a couple of other methods. I trust key code. Now I'm going to, right here, if I hit enter now, it's going to log a 13. That's the key code for enter. If I hit space, it's going to be 32. I want my game to pause when I hit enter and to jump when I hit space. Cool? So for now, right, e.keycode equals, said 13. And pause. Game. For now, let's just make that function. Pause game will do the following. Paused equals whatever pause wasn't. Let's toggle pause. If pause was false, let's make it true. If pause is true, let's make it false. Now, we can do something like this. If paused, if not paused, do the stuff inside this loop. This loop is going to keep running, right? But it's not going to change anything if it's paused. There we go. I just hit enter and it paused. Hit enter again. Cool. Do we see what we did here? It's the most confusing part of this so far.
Did you call handle key down somewhere?
Yeah, right here.
Okay, cool. I just missed that.
Mm-hmm. Cool. And we can even do something like this context.font style, right? You don't remember. Context font. Do you? Context.font equals, there we go. Up, up. Fill text. It's almost definitely fill text. Yep. You can say paused. You can say canvas width over 2, canvas height over 2. If it's not exactly in the center, we have bigger things to worry about right now. Boop. There we go. Cool. Now, notice if I do something like context.fill style equals white, we're going to actually have a little bit of a thing that I kind of want to. Everyone see what just happened there? Do it one more time.
Hey, Nikki, I do kind of want to back up a little bit.
Yeah.
I had a little connection issue. Where are you defining the what is it, the key ID or whatever for the pause?
The key ID? Which
Yeah,
best? Right here?
the key code. There we go. So the 13 is your space button for pause.
Yeah, 13 is enter.
Or enter. Okay.
Yeah. So every key press event has a key code representing the key that pressed it. For enter, it's 13. We can console log E, and I'll show you something real quick. There's
Okay.
also
okay.
right.
I got it. Yeah.
You can also just be like key enter code enter. I think key code means that I don't have to worry about like I don't think it's called enter in all languages. I might be totally wrong. Point is, I've been using key code, and it's friendly for me.
Yeah, no, that's really cool. I was trying to figure out how the key code connected to your pause method, and as we're discussing it, I figured out the logic to it. So that's cool. Thank you.
Awesome. So, anyone know why when I unpause the game, suddenly my rectangle is white?
Oh, because you rewrote the fill style?
Yeah, right here. The easiest way to not have to worry about this, boop, boop, do this. Cool. What I'm saying is, hey, whenever you're drawing a player, the fill style is going to be red. When it's time to pause, fill style is going to be white. Cool. Boop, boop. Now this is gaming. Cool. If this makes you want to go out and buy a new high-end gaming PC, I understand. Cool. So at this point, right, we have given us the ability to start and stop at the animation. Now at this point, my next step is that I'm going to need to start giving this player object a couple of like behaviors, as well as asking it to keep track of its data, right? That sounds like a really good reason for a class, right? So I'm going to create a new file. I'm going to call it player.js. Class player. Cool. And I'm going to make sure that it's imported so I don't end up embarrassing myself. Go do a little console.log hello from player. I refresh the page, and there we go. Cool. Let's do a little coordinate section, right? Coords. I really recognize right now that I'm going to definitely probably regret that, but I can now, for now, I can say new player, just pass that in as our coordinates. Cool. And now player now I can just do player.coords.y is that. And hopefully this gets back to the rectangle being there. And then to actually increase it, right, the way we're doing it, player.coords.y minus equals 4. What I just turned player into is I made it a new instance of a player class right here. Cool. I'm actually going to not put this in the constructor. Let's do this right here. And let's actually start giving it everything it needs. Height is 80, width 40. Great. And we'll see that this all still works because all I did was put that down there. But now, because of that, right, we can actually move this logic into our player class, right? Both of these pieces of logic rightfully belong to the player, right? The player should control how it updates, and the player should should re-render itself, right? So I'm going to create a little update function. We'll create a little render function. We can ignore the render for now, and instead right here do player.update. Right here. You'll notice that the update action still works, right? Cool. And like cut this in, player.render. We can now see, whoop, this is all now behavior that belongs to the player, which is good, right? That's what we want. So now what we can do is we can start, let's take a look at our notes. Turn the rectangle into player. We can start making the player jump. So how do we make the player jump? Basically, right, we have this increase or decreasing at a rate of 4 by itself, right? If we turn this into a variable, we create a little jump method, right? Let's first do this. Console.log. This will make the player jump. Now, in my handle event, right? I forget what the key code JavaScript. I'm just lazy and don't want to code it out myself. Space 32. Great. E.key code equals 32 and player.jump. Hey, when they hit space, run the player's jump method. Cool? So now we're getting this console log action going, right? Cool. So in when it comes to using geometry and or just I realize when it comes to using shapes on in games, right? A very common pattern is to talk about the derivative of y or the derivative of x, the change, right? When I say dy or x or dx, what I'm saying is the change in x or the change in y. For those of you who for whom math is a distant past, a derivative gets the change of something. Take a second derivative, you get the change in that change, things like that, right? So that was my only synopsis of math. But I'm going to create something that I'm going to call this.dx or dy. I'm going to set this equal to 0. Cool? Or I'm going to set this equal to 4 first. Great. Now nothing has changed. I've changed this -4, or this +4 to a variable that we can now use, right? So now I can go right here. If I want to make the player jump, right? We want to make it, hey, when it jumps, the dy becomes 10. And now it goes off the screen when I hit space. Cool? Now, something with a static dy moves in a line. A jump should be an arc. A jump should go up and then like eventually go like that dy should start going back down until it's negative and then it starts to fall, right? Let me show you what I mean by this. Let's say I did something like this dot y is great if this dot y is less than canvas dot height minus 80. This dot dy minus minus. Cool. See what this does for us. Oh. I didn't do this right. I think I did this. Okay, so this, if this dot y is less than great. Let's take a look. This dot coords dot y. There we go. Nice. Great. Let's try this again. There we go. That's the behavior we want. If everyone sees that really quickly, bloop, right? We jump. Suddenly the dy goes up to 10. Let's make this go up to 30. We're very close, right? We have just added gravity to our app. We just don't have a floor that works, right? So I'm just going to make it, hey, if it hits the floor, starts to go through the floor, this dot y equals this dot, or equals canvas dot height minus, at this point, I'm actually going to make this always say this dot coords dot height rather than 80, because at a certain point, we've made this variable, we might as well use it. Cool. And this dot dy equals 0. Cool. Hey, once it starts going through the floor, stop it from going through the floor, set it to the floor, and stop it from moving. Cool. Change the change in y to 0. When you see dy, you should read that as change in y. That's what math nerds do. Really, they just get sad and talk about Feynman, but cool, that didn't work, clearly. Right, if this, I think we need to make sure it's not always on the floor. Let's do this. There we go. Oh, what? Cool, it sort of worked. It's now in the floor. This dot coords dot y. There we go. Continuing to do that. Why do I have a this dot y? Cool. I don't, I think. There we go. That is a jump right there. We now have an app that can jump. It can Flappy Bird too, which is probably a problem. right? We haven't told it, hey, can't jump when you're jumping. This would be a really easy endless runner game. Just bash spacebar a lot of times and run away from the computer. Oh, didn't go that bad. You have to really hit space a lot. But we can solve that problem. We can solve the double jump problem. This dot jumping equals false if this dot jumping is false. Do this. And once you hit the ground, this dot jumping becomes false again. Now, I can still double jump. What? Okay. Right. This dot jumping is true. There we go. Now we can't double jump anymore. Cool. How are we feeling right now?
I'm still a little confused about the dy business. Probably mostly just because you threw the word derivative at us.
Mm-hmm. Set the change in y to 30, right? When you start jumping, right? When you kick off the ground, you add a lot of upwards momentum. Eventually, gravity starts removing stuff from that, right? Until eventually you start having downwards momentum. And then eventually you hit the ground, right? So dy is gaming and math for change in y, right? dy is usually 0 when you're on the ground. When you're on the ground, your height is not changing. Where you are relative to space isn't changing, right? The moment you jump, we're adding a lot of upward change, right? But then while we're jumping, we're having gravity reduce it by 1 every single time the update method is called, right? Every time the update method is called, we're changing what dy is by reducing it. So it goes up less and less until it becomes negative, in which case you start falling back down. Cool?
Okay, that helps. Thank you.
All right. How are we feeling in terms of just where we are in terms of this code? We just built a jump function, right? And we made the player stop jumping. 2 very accomplished things, right? Now that we have this, right? Our next step is we need something to start like coming at the player so that they have to jump at it, right? When you design an endless runner game, you are not running forward along a map that they're stationary on, even if it looks like that. Even if it looks like the cactus, you usually make the cactus come towards the players, right? I haven't looked at the code for the dinosaur thing. I haven't looked at Pony Island's code. Pony Island is the best on endless runner game I think there is. It's like a really indie horror one that really plays with the idea of an endless runner. But basically, regardless, we're going to need some obstacles for the player to jump over, right? And the obstacles we're just going to have coming from the right of the screen. Cool? So here, we can now create a new class that I'm just going to call obstacle, right? And I'm just going to copy all this for now. Bloop. And the only difference I'm going to do, going to name. Oh, interesting. That was a mistake. Make this hello from obstacle. Obstacle. Great. And I'm going to change player to not be to actually just call it this right here, because I noticed that that was a mistake. Cool. And now in my index.html, I'm going to grab this obstacle object. Cool. We get this hello from obstacle, right? Then we can start talking about what an obstacle should do. Basically, I actually want to initialize. Okay, we need to get rid of this iPad version. I want it to initialize just slightly off the page, and every frame just to start coming left. Cool? So first, we can make it, shouldn't be as tall as the player. I don't know. Let's make it 60. Width 30. I don't know. Like eventually we can mess with the difficulty, decide on the gameplay we want later. For now, one difference is we're going to start with the canvas. It's going to do the same thing, right? With Y. With X, though, let's just start at the edge and come in. Cool? It will not have the ability to jump. So we can get rid of this jump feature, right? That would be a much more difficult game. And now,
Nikki, that would be really cool to see as a demo, though, to watch these two things collide.
Mm-hmm. Yeah. We can always have it start doing some random up and down moves if we want to. We can create like new enemies later. But for now, let's just have so that, hey, every time it updates, so we can come in from the left a little bit more. And now I'm going to do this. And I should really make this same thing. First, let's make the bad guys yellow. Oh, come on. Let's make this continue to work using its actual variables rather than just some stuff I hard-coded in at the beginning of the lecture. Cool. So this still works. Now we create a new obstacle, right? You can just do new obstacle. Nothing happens. But if I now do something like const obstacle equals new obstacle, I can say, hey, obstacle.update2, player.render, obstacle.render. Cool. Heck yeah. Honestly, if you make it slow enough, it becomes hard again. Because your jump only clears so much. But we can make it faster now. Boom. I would lose. Cool. So next up, right? We don't just want to create one obstacle. We want to create multiple obstacles. And each of these obstacles will eventually have to not only re-render themselves, but also check to see if they're colliding with the player, right? So here, I'm going to say, I think people are like doing dancer size on my roof. But I can say, hey, this dot constructor dot all dot push this, and I can define a little static all equal to an array. This is the same thing as in Ruby when we did at all, then at all dot push self, right? Or dot shovel self, right? This will allow us to start doing new things. I can now create a deeply confused by that. We've got new people who moved in who are going to ruin the fact that we all sneak up to the roof for everyone. But we can now call this dot all dot for each obstacle dot update. We can also create a static render, right? And now, right, if I were to, instead of like saving this like as a hard-coded obstacle, right? I can get rid of this, right? Take a look what happens. Let's take a look what happens. Great. So I've created a class method for creating an obstacle, right? Or for updating and rendering all the obstacles. And I've made so that every new obstacle is just shoveled into the obstacle, shoveled into the obstacle thing. So that now means whenever I type new obstacle, we're going to get another obstacle showing up, right? We did some cool things and some weird things with static methods, right? So what's the most confusing part of what we just did? Awesome. Well, in that case, we've got make an obstacle, make the obstacles move, make. What am I doing there? So now basically, we're going to have to decide to make many obstacles, right? So right now, we can only call a new obstacle when we type new obstacle. I want to make it like, I don't want to make it like a pattern, right? We're not doing Guitar Hero here, right? So I don't want to like make it so like every 40 frames a new obstacle renders, right? I want to like make it a little bit, I want to make it a little bit random, but I also don't want to ever end up in a situation where there's just two obstacles right one after the other, right? So here we have a cool little thing we can do. This is kind of my favorite way to design it, and say let frame equal 0 frame plus plus. Cool. And now I'm going to create this little thing. Feels like my house is going to collapse. Cool. I'm going to create a little function right here that's just going to say, hey, return a number between 40 and 120 or something. Cool. So I'm going to do and I'm going to say right here, math.floor, math.random, times. So it's between 40 and 120, right? That was what I said? Cool. So I'm going to say, hey, give me a random number between 0 and 80. Add 40 to it. Let's try that out real quickly. Make sure that you got that math right. Get next obstacle frame. 32, 46, 64. Seems legit. Cool. So now, right, I can say something like, if frame is greater than or equal to, or let's say, this is deeply, sorry, I'm cool. Let's actually do something like, this. Let's say, hey, give me a random number that's equal to something between 40 and 120 plus the frame, which at the beginning is going to be 0. Cool. Now I'm going to say, hey, if frame is greater than or equal to next obstacle frame, right? Like, which is this number that I've given it. Obstacle frame equals get next obstacle frame. Grab another number between 40 and 120 plus the frame number that we're currently on, right? And new obstacle. Cool. Create a new obstacle. Set the next frame that we're expecting to be like where we're expecting an obstacle to be a new random number. So we can even do a little console log action here where I do console.log next obstacle frame. Sets this out. There's 95, then it's 197, then it's 242, then 361, right? So now we've got obstacles just spawning randomly, right? Cool. Do you see how that works? And if I pause it, it stops because my frame only increases inside the pause. Cool. What was the weirdest part of that?
For me, it's how you're using frame and adding it to your get obstacle frame method.
Yeah.
Yeah. Do you have to start at 0?
For frame?
Yeah.
You can start at 1, right?
Like that's what I'm confused. Why does that matter?
No, we just need to start at a random number. I can start at
Okay.
any number I want, right? And then basically, so it starts at frame 0, but like the first frame is going to be frame 1, right? Before it animates anything, it's going to turn frame to 1, right?
Okay.
And then I've created this random number that's going to start with when frame is 0, right? So at line 5, it's going to be a number that's either between 40 and 120, right? And once the actual frame that we're on, right? So frame like hits frame 60, if that's the random number. Once it's greater than the next obstacle frame, right? It's going to create a new obstacle for us and then set a new next obstacle frame that's going to be a random number between 40 and 120 plus the frame that we're currently on. So we're saying, so basically what my eventual goal is to say, hey, somewhere between 40 and 120 frames from now, render a new obstacle. And that's what I'm doing. So from
So-
now, right here, from frame 0, or from frame 40, if that was the next time this is triggered.
So why not just start it at 40? Then you wouldn't have to add 40? Am I missing something in the math here?
Oh, yeah, this gives me a random number between 0 and 80. If I want a random number between 40 and 120, I add 40 to it, right?
Okay. All right. Gotcha.
Is this still sketchy to everybody? Basically, every time the frame gets over this next obstacle frame, which is like, hey, this is when the next obstacle should show up, this frame number, right? I'm going to set a new next obstacle frame that's somewhere in the future, between 40 and 120 frames later, and I'm going to render an obstacle. Cool? So now we have make many obstacles. There's one thing that I still notice that we have a problem with, which is that now if I do something like if I console log all the obstacles, right? These obstacles aren't going away. JavaScript is still going to keep doing this math every time, despite the fact that they're off the screen, right? And eventually this could get my computer to start behaving slowly, right? So we could have a remove function right here that just says this dot constructor dot all dot find index this. Hey, grab the index of myself at the all array. This is going to be really complicated unless I show it this way first. Here, to remove something from an array, we can have const r equals. There we go. Now let's do. I love having demonstrated things before. Let's do this. Cool. R dot find index the or quick will give me the item equals quick, and it will give me the index of the array at that item. And I can just do r.splice. Let's set this equals something. Const index equals this. I can do r.splice index 1. And this will remove that from the array. This is just a way to remove an item from an array in JavaScript. Find the index and then call splice at that index with 1. So I'm going to say, hey, const index equals this dot constructor dot all dot splice index 1. Now I'm going to say, hey, if this dot x is less than, or this dot x minus this dot coords dot x minus this dot coords dot width is less than 0. Hey, if the right side of this rectangle is past the left side of the screen, this dot remove. Cool. can test this out now.
Can you add a counter there too?
Oh yeah,
that,
to like for points.
Yeah.
Mhm.
That would work the same way.
We can now do something like this is exactly how we would do. Don't need a new obstacle here. You do like let score equal 0. Score plus plus, right? Every obstacle that we remove adds 1 to your score. So now we can do something like bloop, bloop, bloop. I have no idea if that's how you're supposed to do it, but we'll solve that in a second. 20. All right, we should actually text.fill text equals score. Let's see what that does. Probably something awful. Huh? Right. Canvas dot width over 2. Canvas dot height over 2. Cool. All right, not exactly what I want, but good enough for now, right? Like we now have a score. Cool. Still, easy way to win is just not to do anything. So finally, make the game end when the player hits the obstacle. Here is where we use collision logic. And collision logic is a mess. Basically, it's whenever I'm writing it myself, I spend some time with a whiteboard trying to be like, okay, what's the case when this intersects this, right? And I like do a lot of math and I write a lot of things on the board and I like make sure to do it one step at a time. Don't try to just be like, okay, this is exactly the greater or less than statement that I want. But in the README, I have saved a little way to check to see if 2 rectangles intersect, right? Great.
On this one, since the character doesn't go past a certain point, can't you just say when it hits that point and the character is at the bottom?
Yes.
Is that what that is? More or less?
No, this one also will check width on like either side and doesn't use it as a fixed statement.
That's checking the 2 actual collision.
Mm-hmm.
Okay.
Yeah, but yes, you can do it like that, and I have done it like that a lot. I just happen to have this code here and like it. And so this is saying, hey, if rectangle 2's x is greater than like one side of rectangle 1 or this or blah, blah, blah. If any of these is false, then it's intersecting. Cool. For now, I'm going to use this. I might want to do something later with it. But I can now say check collision. Cool. And I can do something like this. If this dot coords, if intersect this dot coords player dot coords, because we've used x, y, width, and height for everything, right? lose game. And I'll just call this lose game for now. Boop. And I'm going to create a little thing that I'm going to call function lose game. And we can set post equals true. And I can do like a little something that looks like this. And then I'm also going to say hey, get rid of all the obstacles. And we'll see what that does. Because at this point, I've written way too much code. Right, I didn't actually use this. Okay. Now I can do static check collisions. This dot all dot for each obstacle dot check collision. Cool. That was what I called it, right? You have a little bloop. We are not doing anything here. Did I not call this? Great. Okay, that was a little much. It's not doing what we want. But okay, so we check collisions. Right, and then it's going to loop regardless. So we can create a little oh, right. Duh. Game over. There we go. That was the issue. Cool. Now if I unpause it, we can keep going. I should probably set the score back to 0. Right? And now we have a working game.
Quick question.
Mhm.
Can you, so you're clicking, right? That's how you're jumping.
I'm using spacebar. But yeah.
Space. Okay, so can you adjust it if they hold space down long or short, how high something jumps?
Yeah, it's a little bit more difficult though, right?
Yeah, I would assume so. I was just wondering.
Basically
That's
what
with
you would do,
key
right?
up and key down, right?
Yes.
Yeah.
You would there's a lot of different ways you could do it, but the important thing is you would track how long key down is being pressed, right?
Mhm.
Versus key up, right? And then while key down is pressed, right?
Mhm.
You would have some sort of like it would affect how dy
Could you use a
changes, right?
counter? Like,
Yeah, I've seen key down, and as long as key is down, the character continuously moves up. Just because like there's no limiter on it, if that makes sense.
Yeah.
And then the
So
limiter doesn't turn on until the key comes up, and then it drops back down.
mhm.
Does that make sense?
Yeah.
No.
So yeah, it totally does. And I'm trying to think of a way that I can show you that would go a little quickly. We could always save this for like a pod or whatever.
no, that's cool. I don't mean
Yeah.
for you to do it. I just wondered if, like, I figured it was a thing. I just,
You totally can is the
Yeah.
answer.
cool.
I'd be glad to build it.
We can totally do it in a pod. We're already over. I don't want to keep
Yeah.
you any longer. You have a life, I
Mhm.
think.
But yeah, so there's a lot of things we can still do, right, with this code. I think at the bottom of the README, there's a few interesting challenges, right? We added a score. We're done with that. Render a sprite for the players and obstacles instead of a rectangle. Add audio effects, add a health bar. And most importantly, make our game logic into one class, right? But the way we did this was we just used context to imperatively draw like different boxes frame by frame using this request animation frame to like make the game loop happen, and added some logic for how things render. And doing that, you can create like this kind of pattern with the loop and things like that is kind of how we do almost all games. And Canvas and context, like Canvas and context, is a really useful tool for making that happen. Any questions before we end this recording? Awesome.
No, that was cool.
Thanks for joining, y'all.
Yeah,
Thanks.
that was really awesome. Thanks, Nicky.
Great lecture. Thanks.